Okay, so in this video, for those who don't have a multimeter, we're going to look at how you can decide if you have a common anode or a common cathode RGB LED. So I've got one of each, and we're going to test them both and determine which is which. So we'll start with whichever one you have, because there's no way to tell from looking just at the RGB LED which type it is. You have to test it. There are 4 legs. One of them is longer than the others. It'll be the second one in from one of the sides, and you want to figure out which is that longest leg. And once you've got your eye on that one, then fan apart the legs, keeping an eye on that longest leg. And we're going to put this into the breadboard so that each one of these legs is on a different row. And you want to remember which one is the longest. Okay, so for me, this is my longest leg, the second one in. Okay, so the difference between the common anode and common cathode, if you have a common cathode RGB LED, all 3 of the LEDs, red, green, and blue, share a negative connection, a cathode connection. If it's a common anode RGB LED, then they all 3, the red, red, green, and blue, share a positive powered connection. So I'm going to take a male-to-male jumper and connect it to power to test and see if this is a common anode RGB LED. So we're going to run from power on the extension board over to the blue power rail on the side. And then we need a resistor to go from power, and then we're going to jump across to the row that has that longest leg of your RGB LED. And then to complete the circuit, we have to take one of these to ground and see if it lights up. So we're going to start with the outer leg, which let me see if I can turn this to the side so you can see. So I'm on the same row as my outer short leg, and I'm going to connect that to ground and see my red light came on. So I know now that this is a common anode, that the 3 legs, the red, green, and blue, share a positive connection, an anode connection. Okay, if I change that ground, instead of going to the outermost short leg, I'm going to go to the innermost short leg. Now it turns green. If I go to the other remaining leg, that's my blue. So in order to work in Python with this common anode RGB LED, okay, then I'm going to need jumper cables to connect my red leg, so that was the shorter leg on the outside. I'm going to connect that, instead of to ground, which was here, I'm going to connect it to GPIO pin 16, so I can control that on-off switch for that pin from Python. Then the green leg, I'm going to run a green jumper to GPIO pin 20, so I can control green with 20. And then my blue leg of the RGB LED, I'm going to run to pin 21, so I can control that with pin 21. Okay, so now I'm ready to look at my code. Okay, so in Python, I'm going to tell the program that the pin numbers for the red, green, and blue that I just set up, I use 16, GPIO pin 16 for the red. then 20 for the green, and I used pin 21 for the blue. So red, green, blue, you want to enter your pin numbers as parameters into that function. And since this is a common anode, we're going to use the opposite of what we did for the common cathode code. 0 is going to turn on and 1 will turn off. When we're doing LED.red equals 0, that's going to be a full red light. LED green equals 0, that's a full green light. And similarly, to turn off the power, or turn off the LED, we use the command LED on, which is counterintuitive, but remember the anode is the opposite of the cathode, which was what we had coded before. So this program should run and turn our LED on red for a second, then green for a second, blue for a second, purple by turning the red and blue on at the same time and the green off. That'll make purple. And then this loop at the bottom is going to start with a dim light and then get brighter and brighter and brighter blue. So let's look back again at the breadboard and we'll run this code to test it. So there's red, green, blue, purple, and then there's the dim blue that gets brighter, 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 and then once it reaches 100%, it turns off. And so that was testing the common anode RGB LED. Now the other option is if we have a common cathode. So that would be my other one. And it looks exactly the same as the common anode. Again, we're going to test it by finding the longest leg, and keep an eye on that while you fan the others apart enough that you can plug them into your breadboard in 4 different rows. And if this is a common cathode, then the red, the green, and the blue legs all share a ground in that common longest leg. So we're going to test that by running a jumper from ground to the same row as our longest leg. And then we're going to run power. So we'll go to a 3.3 volt pin. And we're going to run that power through a resistor into another leg. So I'm going to go for this short leg down here at the bottom, and then I'm going to jump across that center divide with a resistor, going from the same row as the power to the shorter leg on the outside, and that lit the LED blue. So now I know this is a common cathode RGB LED, where its shortest leg on the outside here is controlling the blue. But I want to control these colors using Python instead of sending power directly in. So instead of running from the blue leg to 3.3 volts, I'm going to run the blue leg to pin 21. And it comes on because the last time I ran this program, I ended with pin 21 turned on. So it's still an open circuit and sending power through that pin. And then my green, I'm going to need a resistor to go from that leg, that short leg next to the blue, across the center divide, and I'm going to run a green male-to-male jumper from that resistor to pin 20. And it changed the color of my LED to an aquamarine kind of color because it's mixing the green and the blue together since both of those pins were turned on when I last ran my code. Okay, then I need a resistor going from my red leg, so the outer short leg, across that divide. And then I'm going to run a red jumper from that row of the resistor to pin 16. Okay, and that should complete my physical computing piece for the common cathode. Now we'll go back to the code and see how that's different. Okay, so the last time we did the common anode code where 0 was full red and LED.on actually turned it off. Okay, now we're going to work with the common cathode, and the common cathode 1 is on for the GPIO pin as well as the LED, and off, LED.off. So I'm going to go ahead and enter that, LED.off. That will turn off the LED each time. So we're going to have it be completely red, then completely green, then completely blue, then it'll be purple. We'll turn everything off, and then we'll have the intensity of the blue changing in this for loop, and then we'll end with the LED off. So let's go ahead and take a look at the breadboard while we run this code. And there's the red, green, blue, purple, and then the intensity of the blue increasing until it reaches its max, and then it's going to turn off, and there it goes.